Right. Hello, everybody. Welcome back to the lecture. This will be the lecture starting our next assignment, which is called More Practice with Proving Triangle Similarity. Okay, so nothing new this week. We're going to continue just practicing what we started on last week. All right, so more practice with proving triangle similarity. A couple of announcements before we get started. There are two sections, or sorry, about 3 class periods that I'm not going to be able to have video lecture this week for, okay? So that's going to be tomorrow, Monday, let's see, April 27th. For B-Day, I won't be available in the morning from 8 to 12. So that means 5th period won't have video conference tomorrow morning, or whenever you see this, Monday, April 27th, Monday morning. Okay, and then Tuesday, April 28th, A-Day, I will not be available in the afternoon. So 2nd and 3rd period, I won't have video conferences for you guys on Tuesday. Okay, so just a heads up. They're letting the teachers back into the school to grab our personal belongings and to start cleaning up our classrooms. They gave us the go-ahead to start doing that starting this week. So they're giving us a morning session and an afternoon session to do that. So that's why I won't be available for our video conferences. But Wednesday, Thursday, and Friday, back to normal schedule video conferencing times. If you do need to stop by and ask questions, or if you want to stop by and say hi, you're more than welcome to do that. I love when you guys do that. So keep that up. So just a heads up, if you log in one day on Monday or Tuesday and the video conference isn't up, and that's why, because I won't be available for that. I'll be at the school getting my classroom cleaned up and everything. Okay, that being said and done, one more thing I want to address. I know that questions been coming up a lot about the rest of the school year. Okay, we have 1 month left, 4 more weeks. Okay, this has not been a pleasant experience for a lot of us. Okay, a lot of us don't like learning online. A lot of us don't like teaching online, and unfortunately, that's just the way it is for the time being. We hopefully by next school year we're able to go back into the classroom. That's our hopes for everybody. However, a lot of students have been asking, Mister, why do we have to keep doing this? Okay. The simple answer to that, guys, and I don't want to go too much into it. The simple answer to that is simply because we don't want to disrupt the learning process. Okay. We're trying to do this as seamless as possible. We don't want to disrupt that. Think of it as like exercising. Okay. We're at home. We haven't been exercising. Maybe we get a little bit out of shape, or we gain a little bit of weight, or we lose some of our muscle mass or something because we're not using our muscles, right? That's kind of like how the brain works and learning and things like that. You want to be able to exercise your brain. You want to be able to exercise, well, your mental capacity. You want to keep that going. Once summer hits, you guys will have a couple months off, a few weeks off to rest and to do all the good stuff. But for now, we're in the home stretch. We're almost there, guys. It's just 4 more weeks of this online learning, and we keep it going for you. You guys have free public education, so take advantage of that. Take advantage of that. It's a lot different once you get into college and you have to start paying for your own classes, and I'm sure you've heard that so many times from your other teachers. But it's the truth. Okay, we've all been through that as far as your teachers, and we know how hard that is to have to go through college and pay for stuff like that. So now that you have your free public education, take advantage of that. Okay, and so that's real quick answer to that question. I'll get off my soapbox. We'll go ahead and get started with the examples here. Now, again, nothing new this week. Okay, nothing new at all, really. It's more practice of what we were doing last week. The questions you're going to have this week are very similar to last week's. It's just more review, more practice. Okay. That being said, since there's really nothing new to expand on, I'm just going to simply go through 3 more examples for you guys. Work them out here for you. That way you have at least something to go by. and you can refer back to these examples while you're doing your assignment. If you need more examples, of course, watch the previous video to this one. But this one, I'll make it real short. We'll do 3 real quick examples on this. Okay. Give me 1 second to get started here. Okay. There we go. All right, so remember, in our examples that we've been talking about, we have been trying to prove that 2 triangles are similar based on the similarity postulates. Okay, the 3 similarity postulates that we have is angle, angle, side, 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 and side, angle, side. Okay, so I'll do one example of each one of those. Okay, let's start with, I think the easiest one always, I believe, is the angle, angle postulate. If you can prove that 2 triangles have 2 corresponding angles that are congruent, you can definitely say that those 2 triangles are similar. Okay, so here's a good example here. We're trying to prove with angle, angle. Angle, angle similarity. So we have to find 2 angles that are congruent to each other. Currently, as the way this picture looks, you have angle Y on this triangle and angle C on this triangle are both 90 degrees. Okay, so that's a big hint. That takes care of 1 angle. Okay, we know for sure that these 2 are congruent. I don't even have to write that little symbol there. We know that those squares show that those 2 angles are 90 degrees, thus they're congruent. So now we have to find a second angle, and if we can find a second angle, we can definitely say that these 2 triangles are similar to each other. All right, so we have here angle 39, we have over here angle 51 degrees. Those 2 obviously are not the same, but we do have a missing angle here and a missing angle here. Okay, what I'm going to go and do is just pick one triangle. I'll go and stick with this triangle, and I'm going to figure out this last angle. Okay. We know that anytime you're trying to figure out a missing angle from a triangle, you can simply take the 2 angles that you currently have and subtract them from 180. Okay, so we subtract 90, and then we subtract 39, which are these 2 angles right here, from the 180. That, of course, is going to get us 51 degrees. Okay, so that means that this one's 51 degrees, and wouldn't you know, we have a 51 also over here. So we can say that these 2 are congruent to each other. That's kind of messy right there. Sorry, I should have anticipated not drawing so big. All right, so we have 90, 90, 51, 51. So that takes care of the other A. Okay, and if you really think about it, 51 plus 90, subtract that from 180 will get you 39, and that's why this postulate works. Okay. You'll see that all of the angles are congruent. You don't have to go that extra step, because really you only have to prove that 2 of the angles are congruent. It just so happens that the third one will fall into place as congruent, and that's why an angle-angle postulate works, because you really only need 2 angles of the triangles, and the third one will automatically, of course, be the same if those other 2 are the same. All right. Now, with that being said, let's go ahead and come up with our congruency statement, because you're also going to be asked to do that in some of your questions. Some questions you'll just be asked, are these 2 congruent based on this postulate? In this case, it's yes. The answer is yes. And then some of your problems like you had last week will ask you to give the congruence statement. All right. So this is what I'm going to do. I'm going to go ahead and make my grid. The grid will always help me organize my thoughts. Okay. On the top of the grid, I'm going to put the bigger triangle. On the bottom of the grid, I'm going to put the smaller triangle. It doesn't matter, just so long as you stay consistent in what you do. That's really one of the big things that I've been trying to get you guys to do. Just stay consistent, because that's going to help everything match up and then give you the correct answer. Okay. The best way to do something like this, if we're going to use the big triangle up at the top, I'm going to go ahead and list the angle measurements from least to greatest. That'll help me. You can do it from greatest to least. However you want to do it, just stay consistent on how you do it. Okay. We want to keep things simple, go from least to greatest. All right. So in this triangle, the angle with the least measurement is angle E, which is the 39. So I'll put that here. The next, the one in the middle between the 51 and the 90, of course 51 is going to be the next bigger one, well, depending on how you see it, small, medium, large, I guess you could say. So the medium number will be 51, that's angle S. Okay. And then of course the largest angle of the 39, 51, and 90 is going to be angle Y. So we'll call it Y right there. All right. Same thing for the triangle, the smaller triangle over here. I'm just going to do it from least to greatest. Okay. The least here is 39. That's going to be H. The middle one is going to be 51. That's W. And then the largest angle is going to be the 90-degree angle, angle C. Okay. Now that I have my grid, I can go ahead and make my congruency statement. Okay. So I'm going to say that triangle SY is similar to triangle HWC. And there we go. Okay. So my answer is yes, they are congruent using the AA postulate. And this is my congruency statement. Triangle ESY is similar to triangle HWC. Did I just call that a congruency statement? I'm sorry, I meant to say similarity statement. Okay, two different things. Being congruent and being similar are a little different. And we've discussed that already. Okay, so you have questions on that? Let me know. Just extra practice. Again, the questions that we're reviewing today. Okay, from that one, we're going to go ahead and move on to our next example. Okay, in this example, the question that's being asked is, determine if the triangles are similar by side similarity. Okay, and then if so, give the congruency statement. So we're looking for side similarity. So that's what we're going to use to check. And you can see here, the only information that we really have is the lengths of the sides of these two triangles. We don't know too much about the angles, only that these two angles are vertical angles, so naturally these two are going to be congruent. But since we're mostly working with side here, we don't have to worry about the angles at this point. All right. So again, let the numbers guide you in this situation. We're going to check for, when it comes to sides for similar triangles, we're going to check to see if they're proportionality. Okay. We discussed that in the last video. Let me go ahead and show you. I'll give you, this is a good example to go over. To see if these sides are proportional to each other. In other words, if the ratios that are set up to represent these two triangles, if they're equal to each other, then they're proportional. And that'll prove to us that they're similar using side. The easiest way to do this, guys, is I'm going to set up 3 ratios using the lengths of the triangles. Okay, I'm going to go ahead and use this triangle first and then this triangle second. And it's really easy how to set this up. Basically, I'm going to set up 3 fractions. Okay, the numerators of these fractions are going to be represented by the smaller triangle, and the denominator of these ratios are going to be represented by the bigger triangle. Okay, so this triangle, numbers on the top, this triangle, numbers on the bottom. Okay, how am I going to write the numbers down? I'm going to let the numbers guide me, and I'm going to list them from least to greatest. That's going to be the easiest way, at least for me, how I think about this. There's other ways of doing this. My way is not the end-all be-all way, but if you find something that works for you, by all means use it. There's always so many different ways of doing things in math, but this is the way that I'm going to model it for you guys. Okay, so hopefully this helps you out. All right, so numerator numbers, smaller triangle. I'm going to label the sides from least to greatest. We have 12, 15, and 5. The least of these 3 numbers, of course, the smallest is 5. Put that right here. Okay. The next biggest number, or the one in the middle, between 12 and 15, I'm going to go with the smaller one, which is 12. And then the largest number, of course, is 15. That'll go way over here at the end. Right? So we're done with that first triangle. We'll move on to the second triangle. That's going to be the numbers at the bottom for the denominator. Same thing. I'm going to list them from least to greatest. Okay. So 54, 18, and 43.2. 18 is going to be the smallest number. That's going to go here. The next one up between 54 and 43.2. 43.2 is the smaller of the two, so that's going to be the middle number. 43.2. And then the biggest number between these three is going to be 54. So 54 is going to go right here. Okay. Now, to check to see if these ratios are proportional, we're going to go ahead and put them into the calculator and see if they're equal to each other. Now remember, in the calculator, we cannot put in 3 different equal signs, so we're going to have to do this 2 at a time. And let me get my calculator up here. Sorry, it should have been ready for us. I'll just edit this out if need be. Is that one in? Yeah, okay. So, menu, add calculator. Okay, we're not using nsolve. Notice in our problem, we don't have any variables. Okay, so this is not an nsolve problem. I know you guys are really good at using nsolve, and a lot of times you get caught up because you're used to using nsolve, and this isn't going to be a case where we're using nsolve. We're not looking for a variable, so no need to use nsolve. It's just going to be a straight calculation. Okay, so let's type in our first fraction, 5 over 18. Control division sign, that'll get us our fraction, 5 over 18. And we're going to see if that's going to be equal to the next fraction over, 12 over 43.2. Okay, 12 over 43.2, 12 over 43.2. Okay, I'm going to hit enter. If these are equal, I'm going to get the word true over here. If they're not, then it'll say false. So let's try it out. True. Okay, so far so good. 2 of the ratios so far are proportional. They're equal to each other. So what we're going to do is we're going to test the last number, 15 over 54. Okay, you don't have to do much. All you have to do is hit up, hit enter. That's going to copy and paste your fraction. And I'm going to erase this fraction and just replace it with this fraction right here, 15 over 54. Okay, so 15 over 54. Okay, oops. If that is proportional, then we've proven that these 2 triangles are similar using the side, side, side postulate. Okay, and there it is. So all 3 of these fractions are proportional to each other. That means all 3 of the sides are proportional. So yes, these are proportional using side, side, side postulate. Now let's go ahead and come up with the congruency statement. I'm sorry, I keep saying that. The similarity statement. Pardon me. I'm going to use my grid so that I can map out which sides correspond to which sides. Okay. This one's a little bit. It's not harder. You just have to. Tackle this a different way. Okay. We're talking about sides, and any side, of course, has two letters that correspond with it. Okay. So this is how I'm going to do this. Okay. I'm going to look for the smaller triangle that's going to go on the top. Okay, the smaller triangle, the side 5 is the smallest side. That's side PR. Okay, PR. I'm going to go and say, well, I'm starting from this side and moving towards the middle to the angle that's shared by both triangles. So I'm going to write it as PR, the first set of vertices. Okay, PR. Okay, now this 5 corresponds to the side that's 18. 18 is right here. Okay, now the pattern that I chose was kind of from the outside into the middle. So that's the same thing I'm going to do here, from the outside to the middle. So side YR corresponds to side PR. Okay, so YR. And then basically the last step is just put in the one point that we haven't used yet. Okay, on the smaller triangle, remember these are the smaller triangle values. That one last vertice that we haven't used is the letter A, so that'll go here. And the one that corresponds to that one is the last letter on this triangle that we haven't used, which is T. So that T is going to go here. Okay, and let me just make sure that this is correct. Yep. All right, so now that we have our congruency, our grid that maps out what corresponds to what, we can go ahead and write our similarity statement. And that statement is that triangle PRA is similar to triangle YRT. YRT. Okay, and there's your similarity statement for that one. That's going back again to side, 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 similarity, or the postulate for side, 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 similarity. Okay. All right. One last example here. Don't want to take up too much of your time. Is going to be side angle side, and let's go ahead and take a look at this example right here. So the question being asked, determine if the triangles are similar by side angle side similarity. Okay, this one is probably one of the more difficult ones. The order that I'm showing you them, it's like the easiest one to like the hardest one. But it's not hard, it's just a little different. We have to know what we're looking for. So if we're looking for side angle side similarity, notice that the A is in the middle of the two S's. That's a big hint because the angles, excuse me, the angles that have to be corresponding and congruent to each other in this picture has to be the angle that is in between the two sides. Okay. What that means is, for example, if we were checking up on this angle, okay, this angle is between this side and this side. You can kind of see that these two sides even point to that angle. Okay, the sides will point to that angle. Whatever angle those two sides that you're checking point to, that's the angle that's in between the two sides. And that's why the angle, is in the middle. Okay, so that's going to be a big thing that you have to check on. If the angle is not in the middle, you can't use it for the SAS postulate. So let's go ahead and take a look at that then. These pictures are kind of sometimes a little bit hard to understand. What we're looking at here is a smaller triangle within a bigger triangle. Okay, so you can see that this small triangle QWR shares this angle, angle W, with triangle SWZ. Okay. From the simple fact of how this is drawn, that this smaller triangle is kind of tucked into this corner, you can safely assume that angle W is congruent to both triangles. Okay. If you can, for this postulate, if one of the angles is congruent, so far so good, you can continue on with this postulate. Okay. Now, the trick is to see if the sides are not congruent, but what's the word I'm looking for? Proportional. Okay, the sides are proportional to each other, right? So the way we're going to check that basically the same way we check for proportionality in this problem. Okay, in this problem we set up our fractions, and if they were equal to each other, they were proportional. Now the nice thing about this example is that you only have to check two sides. Okay, the two sides that are on opposite or on the sides of the angle that's included in between. In other words, this side and this side. Okay, if these two sides are proportional to each other with this angle in the middle, then we can say yes, these two triangles are similar to each other. All right, so let's go ahead and do that. Same thing, I'm going to go and set up, instead of 3 fractions or 3 ratios this time, I only have to set up 2 ratios since I'm only looking at 2 different sides, not all 3 of the sides. Okay, so that kind of makes it a little simpler. All right, I'm going to go ahead and use the top part for the smaller triangle and then the bottom part for the bigger triangle. Okay, so with that being said, right here on this triangle, I'm going to go ahead and put the smaller value here and the larger value here. I'm going to list them from least to greatest. Okay, so if we look at the smaller triangle, we have side 14, we have side 15. What's going to go first? Side 14. That's the smaller of the two. Okay, the biggest one of that smaller triangle is going to be 15. So 15 is going to go here. Okay, same thing here at the bottom. For the bigger triangle, I'm going to list from least to greatest. So the smaller side here and the bigger side here. Okay, now the big triangle, if you notice, we don't know the whole distance. We know some of it up until here, and then the rest of it up until here. So what we have to do is add these two numbers together. Okay, so 3 plus 14, that should get you 45. So the whole thing here is 45. And on this side, the whole thing here from 28 to 14, if you add those two together, is going to be 42. Okay, so 45, 42. Which one is the smaller of the two? 42. So that's going to go first. Okay, and then the larger number is going to go here. Remember, we're listing from least to greatest. Least to greatest. Okay, so now, if we can determine that these two sides or these two fractions are equal to each other, then we can safely assume that these two triangles are similar based on the SAS postulate. We're checking for proportionality. Okay, so let's go ahead and do that. Back to our calculator. I'm going to get another division sign going. First fraction is 14 over 42. 14 over 42. Equal sign. Another fraction, second division, or control division. And our second fraction here, 15 over 45. 15 over 45. All right, hit enter. We get a true statement. These two fractions are equal to each other. That means that they are also proportional to each other. So the sides are going to work out. All right, so yes, the answer is yes. Yes, we'll put yes here. And now that we know that they're proportional, now that we know that these triangles are similar to each other, let's go ahead and write our similarity statement. This one's kind of easy. Since we know that the angle has to be in between the two sides, I'm going to put the angle name right here in the middle. Okay, so the angle that we used to check for proportionality or to check for similarity, which was congruent on both triangles, was angle W. Okay, so I'm going to put angle W right here, angle W at the bottom too. Since both triangles share this angle, both triangles are going to have the W in them, okay, in the name of the triangle. All right, and then from there, left to right, least to greatest, we can do it that way too. Okay, between 15 and 14, 14 was the least. The point that connects to that W is going to be R, so R is going to go here, R. And then the bigger of the two, which is 15, that connects to point Q. So Q is going to go right there. Okay, least to greatest. That's the way I see it. I'm sure there's a lot of different ways that you can write out your similarity statement, but that's what makes sense to me in my head. If something else makes sense to you, definitely try that out. Okay, so same thing, we want to see which sides correspond at the bottom. So again, least to greatest. Okay, between the two, 45 and 42, the smaller one is the 42, and the side or the point that connects to this W is going to be point Z. So Z is going to go first, and then the bigger one, which is 45, that W connects to S, so S is going to go right here. So now I've lined up all the corresponding angles or the corresponding points or vertices from the two triangles, and now I can write my congruency statement. So I'm going to state that triangle KWQ is similar to triangle ZWS. ZWS. And that's my answer. Yes, we did prove similarity using the side angle side postulate. And what is my similarity statement? There it is. Okay. So it's pretty much the same thing as you guys did last week. 10 new problems, same concept though. Just wanted to show you 3 more examples very similar to what you guys did last week. Okay. All right. If you guys need anything, let me know. Send me an email. Send me a Schoology message. Come to the video conference if you want to talk live. But if not, I hope you guys are happy and healthy and doing good. I miss you guys. Can't wait to see you all next school year. And yeah, hope you guys are happy, healthy, and staying safe. Okay. Wrestling shirt of the week, Royal Rumble 2019. Too sweet me, baby. Woo! See you guys next time. Take care, guys.